Okay, so here we have this problem from section 6.2, which is volumes, number 9. And the directions say, find the volume of a solid obtained by rotating the region bounded by the given curves about the specified line. Sketch the region, the solid, and a typical disk or washer. And the equations that are given are y squared equals x and x equals 2y, and it's supposed to be rotated about the y-axis. So when we graph it, we get this sideways parabola and this line cutting through it. And we have two intersection points, one here and one here. And first we need to find where they intersect. And in order to find them, we need to set the two equations equal to each other. So we get y squared equals 2y, then y squared minus 2y equals 0, and then solve for y. So we get y equals 0 and 2. So we know that the two intersection points are going to be at 0, 0, and at 4, 2. And since we're going to be integrating this solid in respect to y, we know that the region is going to be bounded between 0 and 2. So when we graph the actual solid, it looks like a cone, and it's a washer with the outer radius 2y and the inner radius y squared. So when we integrate it, we need to get the pi, then integral from 0 to 2, because those are the points in which it's bounded by, of the outer radius squared minus the inner radius squared. So when we put it together, we get pi times the integral from 0 to 2 of 2y quantity squared minus y squared quantity squared dy. And once we start solving it, before we integrate, we get pi times the integral from 0 to 2 of 4y squared minus y to the 4th dy. And after we integrate, we get pi times 4y cubed over 3 minus y to the 5th over 5, and then we need to evaluate it from 0 to 2. So here when we plug in first the 2, we get this whole thing, and then minus when we plug in the 0, but then everything's going to go out to 0, so that's just going to be nothing. So we just need to focus on this. So after we do all the calculations, we get pi times 32 over 3 minus 32 over 5, which gives us 64 pi over 15. And that's the volume of this region right here, this solid.